Hello, tonight we're going to work on the converse of the Pythagorean theorem. And first we might want to remind ourselves of what the Pythagorean theorem actually states. It does state that if a triangle is a right triangle, then it satisfies the condition a squared plus b squared equals c squared. And so what we're going to do with the converse is we're going to look at, well, what happens if a squared plus b squared equals c squared is satisfied? Then we have a right triangle. And so the first example kind of highlights this exactly. As we look at it, I can look at saying that 9 squared plus 12 squared, does that equal question mark 15 squared? And so 81 plus 144, does that equal 225? 81 plus 144 is actually 225, and so 225 equals 225, and check. And we kind of knew that already because 9 is 3 times 3, 12 is 3 times 4, 15 is 3 times 5, so it's really just kind of a 3, 4, 5 right triangle, which we had seen when we worked on our Pythagorean triples. Okay, so this triangle is a right triangle. But a lot of times we're going to be given problems that don't necessarily have nice, easy numbers. And so how do we verify those? And so as I look at this example number 2, I see one of the sides is 4.5, another side is 4 2/10, and the third side is 3.5. And the question is, would that one work? Well, I don't associate this with any sort of Pythagorean triple that I can think of. And so I kind of have to work through this authentically. And so I might look at 3.5 squared plus 4.2 squared. Does that equal 4.5 squared? And so a lot of this is going to be use of a calculator, but 12.25 plus 17.64. And clearly what I can see is that the sum of those two values is much greater than 20.25. So 29.89 versus 20.25. Well, they're not equal. And since they're not equal, that means that this is not, this triangle is not a right triangle. So if I was being an inquisitive student at this moment, I would wonder, does this indicate anything else about it? And so if the sum is greater than the single value, so a squared plus b squared, if it's greater than c squared, what this does actually tell you is that it's acute. And so not only can you use the Pythagorean theorem to tell if you have a right triangle, but you ultimately can use it to tell if you have an acute or an obtuse additionally. And so you go back and you go to a third example and you're looking at it, and 170, 154, and 172. And in truth, I don't know if that's a right triangle. I don't know if that's some sort of multiple of my 3, 4, 5, my 5, 12, 13, my 7, 24, 25. So I'm kind of at a loss, and the only way I can really work through this is if I use the Pythagorean theorem converse. And so I look at it and I say, well, 170 squared, does that equal 154 squared plus 72 squared? 170 squared is 28,900. Does that equal 23,716 plus 5,184? And again, reliance on the calculator, very important at this point. And so 28,900. And shockingly, both equal 28,900. So this is a right triangle. And you keep going through these examples So then you have the next one. And so I checked, does 9 squared plus 40 squared equal 41 squared? And so 81 plus 1600, is that 1681? And 1681 does equal 1681. So again, we have a right triangle, which is a kind of nice result. So just a few more examples just to give us something to think about. And so as I look at this, this looks like a right triangle, but let's check it out. The numbers in the diagram below indicate the units and lengths of each side of your triangle. Is it a right triangle? So does 10 squared plus 34 squared equal 36 squared? So 100 plus 1056. Does that equal 1296? And although very close, they're not equal, and so this is not a right triangle. But in this case, as you'll see, the single value, the largest value squared, is actually greater than the sum. And if that occurs, you end up with an obtuse triangle. So if I write this out, if a squared plus b squared is less than c squared, then you have an obtuse triangle. Okay, and I'm just going to bring back the previous example where it didn't work. Kind of basically describe it like this. Essentially, you're summing up these two lengths, and the longer this is relative to the sides of the lengths, you extend yourself past 90 degrees when that occurs. And so that's the situation that we were in right here. It was really, really close, but it just didn't work out exactly. Okay. So our next one, 2 squared plus 6 squared, does that equal 7 squared? 4 plus 36, does that equal 7 squared? This is 40. Forty does not equal 49. And as you can see from the diagram, you have an acute triangle. And the last one, 6.5 squared equals 2.5 squared plus 6 squared, 42.25 equals 6.25 plus 36, and it does. And so here we have an example of a right triangle. So in short, the converse of the Pythagorean theorem states that if the side lengths of the triangle ABC satisfy the condition a squared plus b squared equals c squared, then the triangle is a right triangle. If the side lengths of A, B, C do not satisfy this, then it is not a right triangle. And that's your big takeaway from today. Thank you for your time.